Alright, hello everyone. So today we're going to talk about the key features of a line. So we started a new unit about linear equations. Linear meaning line. So we're going to talk about how to graph lines, how to find the equations for lines, all kinds of stuff during this next unit. Alright, but today I just wanted to start at the key features of a line. And for us, we're going to have two main ones. That is going to be the y-intercept and the slope. These are the big ones that are going to be a part of every single thing we talk about this unit. So they're big. All right, so let's start with the y-intercept. The y-intercept is going to be where the line crosses or touches the y-axis. All right. Well, where's the y-axis, Miss Fields? Well, I will tell you, it is this one. That is our y-axis. So on the other side over here, I'm going to write that y-axis, and it's going to go up and down every time. So I'm going to highlight that just so that we know. And then I'm also going to put in the other axis we have. That's our x-axis. That is going to be the one that goes from side to side, and that is going to be this one right here. That is our x-axis. All right. So like we were saying before, the y-intercept is going to cross the y-axis. So I'm looking at my line. My line is right here. I see it's going to cross the y-axis right here at 2. So I'm going to put a dot there. And I'm also going to label it y-intercept, just so that I don't forget where it is. Now, I'm going to add something to this, and that's going to be x equals 0, because that's also where our x-intercept is going to be, anytime x equals 0. So looking at our graph here, so we could show that visually, our x value here is just 0. We don't go over to the sides at all. We are at 0 for our x value. So, for example, if we wanted to find the point of our y-intercept, it would be at 0, comma, 2. Oopsies, 2. That is that point right here. Our y-intercept is at 0, 2. Okay. All right, so that's our y-intercept. Let's talk about our slope. Now, our slope is going to be a little bit more complicated. It's got more stuff going on here. So I'm going to zoom in a little bit so we could get a closer look. So our slope is going to be also known as our rate of change. Now, our slope is going to tell us how steep our line is going to be. So another way to say that is going to be the slope is the difference between 2 points. Oopsies. 2 points on the line. Okay. Difference between 2 points on the line. So we're going to need at least 2 to look at or calculate, as you'll see later. Okay. Another way that we talked about this probably in 7th and 8th grade was rise over run. So that's going to mean to calculate the slope, you're going to need to know how many units it's moved up or down, and then how many it went over. So that's what our rise is the up and down, our run is the side to side. So let's write that another way. So we said rise was up or down, and that's over our left to right movement. Okay, or another way to say it, in mathematical terms, we use this little triangle to say the change. So the slope is also the change in y over the change in x. That's another way that we can say that. Okay, so let's take a look at our graph for this. All right, so I'm going to take a look at this lower quadrant. This lower quadrant down here. So I want to find 2 points. I'm going to take this one and this one. That is 2 points on our graph. I want to find the difference between the two. I want to find the rise and the run. So the rise we're going to calculate by counting how many units it takes to go from one point to the next. So I'm going to start down at the bottom here and count how many it takes for me to go up to the next point. Okay, so I'm looking at this. It takes 1, 2 boxes. So my rise is going to be 2 because it took 2 spaces to get up to the next point. All right. Now I need my run. How many over do I need to go? How many over? It looks like it just needs 1 box. So my run is going to equal 1. All right, so now before we said our slope is going to be the rise over the run. So slope is equal to the rise, which was 2, over the run, which was 1. So our slope is 2 over 1 for this. Okay, so what if we don't have a graph? Sometimes we'll have problems where we only know the 2 points. We won't be able to see a physical graph. So what we do in that case, I'm going to take us over here, is going to be using the slope formula. So slope will be equal to y2 minus y1 over x2 minus x1. Now, this is huge, incredibly important for us to know. We're going to use this quite a bit. So let's do an example here. So I'm going to take these 2 points from this side of the graph. I'm going to take these 2 points here, and then we'll check it and see if our slope was correct. So those 2 points that we had over there for our example here, we had -2, -2, and we had -3, -4 at those 2 points. Okay, so I'm going to label these. Every set of coordinates has an x and a y. So I've got an x1 and a y1. Why is there a 1? Because that's our first point. Okay, so then we also have an x and a y for the second point. And since it's second, I'm going to put a 2 next to it. All right. Now, what I'm going to start doing next is plugging each of these into where they go in our formula. For instance, y2 is equal to -4. So I'm going to put -4 in for y2. Same thing for y1. It's going to go in there. And then x2 is going to go right here, and x1 is going to go right here. All right, so let's do that just so we can see. So for the slope formula, I need y2. Okay, so I'm going to look at my different points here. y2 is equal to -4. So I have -4. Then we have a minus sign. So I'm also going to put a minus sign. And then we have y1. y1 is -2. So I'm going to put in a -2 over here. Now I'm going to put this -2 in parentheses just so I don't confuse myself, because it could be fairly complicated. So I'm putting in those parentheses to show that I have 2 separate negative signs here. I have one here that goes with this problem, and then one here that goes with this number. So that's 2 different negative signs. All right, let's keep going. So I'm going to need x2 to go right here. x2 for us is going to be -3. So I'm going to plug in -3. Next, we need a minus sign. And then we need x1. Our x1 is going to be right here, and that's -2. So once again, I'm going to use those parentheses. All right. So this looks a little complicated, particularly this part right here. So I'm going to simplify it a little bit before we go on. So we have -4 minus a -2. So we have a negative and a negative here. Now, these parentheses, if we remember from last time, whenever we had parentheses, we could distribute with those. So what I'm going to do is distribute this negative to the inside of my equation. Remember, when we distributed, that meant multiply. So I'm going to multiply negative times a negative here. Negative times a negative is going to give us a positive. So what I want to do is just turn this into a huge plus sign. We have a negative times a negative. That's going to give us a positive. So I have a positive plus sign here, just so that we can make that a little bit less confusing. I'm also going to do the same thing to the bottom because we have that same situation going on down there. All right, cool. So now from here, I am just going to solve straight across. I'm going to do the top first and then the bottom. So the top, we have negative 4 plus 2. All right, negative 4 plus 2 is going to be negative 2. And then on the bottom, we have negative 3 plus 2. That's going to be negative 1. All right, I also see one more thing here. So I have a negative on top and a negative on the bottom. Negative and a negative will give you a positive. So I have 2 over 1 being positive. All right, so we got a positive slope here. The last thing we talked about in this bit was what we see visually with positive and negative slopes. So I can see in our line here, this line is pointing upwards. So I have a line that looks like this. That's going to mean we have a positive slope, just like we've checked. Okay, so then that would mean a negative slope would turn down. We would have a downward arrow if we have a negative slope. Okay, so that was about it that we did on this sheet here. This was just a small half sheet of notes. But let me know if y'all have questions. You know, the usual. This was a little complicated, but that's all right. The main thing you're going to need here is going to be this slope formula right here. We're going to use this quite a bit, especially at the beginning of this unit. So make sure you got that understanding down there. So I'm going to post an assignment hopefully very soon. But that's about it. All right, have a good day, y'all.